Hello, everyone. I hope you can hear me and see my screen. So let me start the slideshow and we can begin. So today I want to talk about ingestion of test sensor data and how to build an architecture for your ingestion pipelines. What are the sort of bad practices, how to avoid them, what to improve, and what to avoid. So let me quickly introduce myself. I'm Thomas Neubauer. I'm a CTO and co-founder of Quix, and I have spent my whole career working with some shape or form of sensor data, whether that was from fleet vehicles or from F1 cars on a track, coordinating first emergency vehicles together to save patient, during the crash on the road or doing a skiing, for example, up to connecting high-speed railway in Asia to detect braking or suspension failures using machine learning models. And all of those had some sort of sensor data. Then we moved to wind tunnel examples where you're connecting to sensors on a test rig, simulators, and heat chambers. There's all different sources of sensor data that you want to ingest. So this is where I'm coming from. And today I want to talk about experience from those projects and what I saw and what you can avoid and improve. So one of the interesting use case was the F1 telemetric acquisition. So there were a couple of different channels to get sensor data from F1 car. One was actually a car on a track, one was the wind tunnel, and one was the simulator. So you have three different machines, but at the end, you want to cross-reference this data and understand them. It was lots of data, some of the sensors producing more than kilohertz frequency. So that means more than 1,000 numbers per second. So it was a quite challenging use case. Also, enabling cross-domain experts to work with this data later is another challenge in these scenarios. So let's talk about the architecture. And let's start with actually what you normally see when you go to a typical test rig where the test data are being collected. So the most common thing I have seen so far is you have a machine which you connect to with some desktop application on a computer in a test room where your machine is located, um, and or factory where the machine is located. And then on that laptop or computer, you run some software that connects to this proprietary interface, and then in a worst case, dumping data on a disk. A very worst case is actually dumping it on the laptop or computer hard drive, and then people using flash drives to move data around. In a slightly better case, at least it's being uploaded to a shared drive in the network. Then we sometimes see some combinations of different softwares and technologies. So, for example, Agilent uploading data to SharePoint. Again, not a brilliant solution because SharePoint is not really a data source in a data stack. Sometimes we see LabView producing files, again, some folder somewhere on a network. Slightly better case, but still full of issues, is where we see some collectors being deployed to the actual test rig, and then these collectors save it to databases. So for example, we have seen many times a telegraph connecting to one of the technologies that telegraph supports, which is a lot, and then syncing it directly to a database. Now, because that is not often a reliable solution, sometimes we even see some database replications, etc. But ultimately, what's happening is that when the data lands in database, then being pulled back with some bad job to do some post-processing, data normalization, data cleaning, or data downsampling, simply because usually the data not coming from the machines in a format that a data consumer, being a domain expert, data scientist, mechanical engineer, or simply somebody who will look at the data and make sense of it, would found practical. By the way, if you have any questions, please use the Zoom interface. There's a question. There's a possibility to ask question. I will look at them at the end. So this is much better example, and we're gonna together do this today. So I'm gonna program this example to show you how to do it. But basically what we're getting here is a local gateway running on the premise. So that still could be that computer, that's fine, which is sending data over some HTTP gateway to your data platform in cloud. Now, what is very important here is we basically trying to get as soon as possible to a data platform. Now, there are many reasons for that, but we chiefly start trying to minimize an amount of real estate where you can make some mistakes. Because if you do a mistake in ingestion pipeline on premise, the data is usually lost. Whilst when you do a mistakes on a write, you can reprocess them because there are features and technologies that allow you to reprocess data. And we're gonna do that together today. I'm gonna show you why you want to do a business-related logic in a write side, because if you do it wrong, you can always go back. Even better, I would say, is something like this, where you have MQTT broker on premise, which either is directly connected to the machine, or you can think of a local gateway between the MQTT and the actual machines. That's just a detail here. But then going to MQTT to your data platform, and then you process it there. Now, I want to steer your attention to the right, which we're going to cover more in detail in the next episodes, but we are not saving data directly to database. We're saving it after we pre-process it. But because we want to be able to reprocess the data if we have done something wrong in pre-processing, we also persist the raw data into a blob store so we can reprocess this data. Cool. So what we also often see is that because the data are not coming out of your machine in a format that would be practical to use, people put transformations to collectors, whether that's a telegraph or whether that is just a simple script running on a local machine in a test rig room, trying to just manipulate data in some way or form to change it. Sometimes we see things like files being dumped on a disk and then being listened to, loaded to the memory again, do some changes, and then send it to database, things like that, which again makes the maintenance of that system quite unpractical. So let's talk about the actual data. So if you look at different technologies, how to get data, and we have talked about files, we have talked about HTTP API, MQTT. They each have slightly different sort of schema or format how you would usually get the data. It's not always the case. I mean, the MQTT, for example, can really deliver data in different formats, but I'm just going to talk about a typical way how you usually would get MQTT data in a client. And that is something like this, where you basically have a path in your topic, which would go into the tree structure of your organization, or rather topology of your machines. So if it's just a couple of machines, usually you have a machine ID slash sensor name. If it's a more complex situation, you can have, for example, a room slash machine slash the module slash sensor. And then in the payload, you would see the number representing the value of the sensor, or a binary if it's something more complicated. This is how the MQTT deliver data. Of course, I have seen many times where that is not honored, and you send data in a JSON payload where you kind of replicate different technologies like Kafka. But I would say I don't think that's the right thing to do. I think this is how people expect MQTT to work, and the tools and run MQTT works like that. There are also interesting features around MQTT topic system. So I would set it this way anyway. But this is not how we want to use it. And definitely it might not be the best way how to save it to the database or files in a blob store. So this is why quite often we will see a data transposition straight after the ingestion to columns, which would render data to look like something like this. And we're going to do this in a practice, in a code together today. Now, this is not end result, because you see that we have a lot of gaps now data, and we still can't really cross-reference the data for our analysis. But I'm just showing you the first step that you want to do after the data lands in your data platform. But this is a crucial thing. You do this in a safe zone of your data platform. So if we go back here in a blue rectangle after the MQTT source, you don't do it somewhere where if your message is being not processed because of some bug in your code, you lose them on the floor. But eventually you want to end up here, which is something we're going to do in the next episodes in detail. I'm going to program it. It's a stateful operations downsampling. So this is where you get some quality, nice data for your domain experts to query and make sense of it. So the second thing, which is quite important, is the actual configuration. So imagine here we have a 3D printer, or actually, no, normal printer, which has a temperature and humidity, and has also a configuration of a toner. So you have a test rig where you're testing different toners, and every time you put the toner in the printer and you run the test, you associate that toner with complex configuration. That could be what manufacturer of the toner, what is the content of the cartridges, etc. Now, I have seen different ways how to handle this exact scenario, almost exclusively wrong. One of them is where you send the payload with every message, which is obviously increasing your bandwidth a lot unnecessarily. Then second way how people send this is they send a message at the beginning or when the metadata are available, and then they send the sensor data. Now, this has a problem of that what if you join the stream later, and as a result, you have to make every processing service downstream a stateful, which is untrivial operation, and it's not for free as well. So it's better to do it differently, which I tried to kind of demonstrate on this diagram. So basically, you have one channel for your periodic time series data, and then you have a different channel for your configuration. Quite often, also, you save it to a different database because there isn't a database in the world that would handle configuration data and time series data at the same time and give you good experience. That's why most of the time it's the best to have two databases, one per each, and then you join the data when you need it. And you just join the part of the metadata that you actually need to join. So for example, we might have here a complex XML, but actually we just need to join the toner type so we can index it as a tag in our Influx database. Okay, we don't need to drag around the full XML everywhere. So this is quite crucial, and it allows you to make an experiment management layer on top of it, which allows you to look at the data with the lens of experiments and overlay different experiments data results versus changes in the configuration, because sometimes you want to understand why the temperature of the probe were higher, and you just see that actually what changed is that the toner had a different manufacturer of the ink, for example. So yeah, that is for the slides. So let me switch to the practical session. I'm gonna check if there's any question before we go there, so we can possibly answer them. Chat. I don't think there are any questions, but it's a bit, yeah, there's nothing. Okay, cool. So let me switch to the actual platform and let me show you the simplest part. So here I created an empty project called webinar, and I have HiMQ broker, so I can go there to show you here. And this cluster has some data that I'm going to use for this webinar. And so first thing I'm going to do is I'm going to go to deploy a connector and choose MQTT source. Here, I'm going to create a raw topic. Now this topic is going to be bronze. This is data that we haven't touched. Now here, this is super important. This is the beginning of the safety zone. From this moment, our data enters a redundant, duplicated broker where it's protected against hardware failure. There is a retention on your data for amount of time or amount of data that you specify. So if you have any problem in your downstream processing, you can always go back. And we're gonna simulate that scenario today to show you why that's so important. So I'm gonna create 50 megabytes buffer here. So we have 50 megabytes time to fix, so we can go 50 megabytes back in a time. So let me copy the URL here. And the port is the same. The username is admin. I have pre-added the MQTT password to secret management here. So I don't have to do it here. And that's it. Okay. There was some interesting error in creating topics. Let me restart service. Okay, well, it seems that this environment is not working. So I'm going to create an environment in a different, I'm going to create a webinar too and use a different Kafka. It's unfortunate. I'm going to use the same branch, so we should have that connected there already. And let's stop that. Okay, so that seems better. So now this is connected to that broker, and soon it's gonna give us some data. I'm going to make sure that my producer is actually producing data. It's not producing for the same reason, so I'm gonna create a new environment here as well in a different Kafka, just to get some testing data for us. So what we're doing in this environment is we're getting OPC UA data and we're syncing them to MQTT broker, which is to sort of simulate the local environment on premise. So if we go back here, that's basically this side on the left on premise. Good. So this is producing data now. So if we go back to our environment, to our webinar 2, it's going to pick up this data and hopefully soon give us some messages. So let's check the situation here. Yeah, that's producing data. And this is syncing data. Cool. So now we have data here. And if we go to messages, we see what we have discussed in a slide. So we see a 3D printer here, print speed, bed temperature, nozzle temperature, fan speed, and just the values. Okay, this is typical for MQTT data, and this is how we expect it to see. But let's create here a first application to make sense of this data a bit more. So I'm going to go and from template, I will create a starter transformation. And I will call this a data normalization. We're going to do a bit more here in the next episodes after this, because there's more to normalization than just reshaping the schema. But we're going to start the first part here. Cool. So now what we have is a first template that basically going to work out of box. I'm just going to remove the comments. I'm going to comment out the output topic because we don't want to produce data to output yet. And I'm going to just press run to see if we connect the data. Cool. So now we have in our Python this exact data we just saw in the preview. So let's first get rid of this and maybe let's print as a table, just so we understand what we're getting here. Okay, so that's what we have. So first we have to do a transformation where we get a value, key of the message, timestamp of the message, and headers, and we do something about it. And then, of course, we have to enable metadata later. So first, we're going to get a timestamp. Now, that's luckily simple. And then we're going to parse the topic to get an information from it. So first part of the slash you see is the machine name. The second part is the actual sensor name. So let's first get a machine name, which we know that is in a key split first part. And of course, you see the B in front of the string. That's a common catch. We have to deserialize the key as a string. And then we use the name of the sensor. So here we're going to say sensor name, or let's put the ID. That's a bit easier, make more sense. And let's do the key split, something like that. And then the actual value, which is easy, which is something like that. So now if I print this without the metadata, just so it fits into our screen. Yeah, we forgot here to enable metadata. That's where we get the key, timestamp, and the header. All right, so now we're getting this data from the machine. Now this is artificially slowed down, so you have ability to read what's actually getting to your service. But you see, again, it's a row structure. And this is where we do the last bit of this data normalization, which is we will convert the rows to columns. It is a longer process than this, but let me just give you the first step of that. So you still possibly want to do a timestamp, maybe that you don't even have to. at this point, and you do a machine, and then here you create a column which name is our sensor ID. And the value is the value. How this is going to look like. It's going to be rather interesting. Oh, hello. So this is like, you have a machine gun firing the sensor values around yourself. This is why this is not the end result. We're going to have to do some normalization, but we don't have a time for that today. So we're going to catch up on that next time. But you see, this is where we're getting to something more practical for our later analysis. So let's stop this. Let's deploy this as a service. Actually, I was too fast. We forget to output this to the topic. We also forget we want to partition it by machine, because we don't want to partition it by sensor as it used to be from MQTT. And we also want something better than a transform. So let's call this, I don't know, sensor data. Now this is a silver topic. Nice. So let's put this to sensor data and let's start it. Amazing. So now you see it's much faster, possibly too fast for the screen share because now it's not throttled, but it is working. So if we go to messages to output, we see that there's a printer one, and in each message we have a machine and the nozzle temperature, print speed, fan speed. It's not what we want yet, but it's a middle step to make it happen. But sometimes you're getting data from different sources. Sometimes some machines allow you to get MQTT, some will not. This is what we discussed in our slides, where, if you go back here, sometimes we have files, sometimes we have HTTP, sometimes we have MQTT. So what we can do is, for example, here, create an HTTP endpoint and normalize it to the same schema. What you basically want to do is you want to abstract your data architecture from a particular technology of a data source. That's because machines can change, the data acquisition can improve, and what you don't want to do is to rebuild everything from scratch all the way upstream to your source and downstream to your persistence and data analysis. So imagine I have another printer, maybe an older one, which I can't connect to MQTT. And the only way I can do this is by sending data to HTTP endpoint, because HTTP is much simpler technology than MQTT. So if I go here and create a connector, and I choose HTTP API source, amazing. So what this does is it deploy a microservice with API, which we can call. We also have a Swagger like that, and we can give it a try. So let's go back here and let's borrow a message from here. So let's do something like this. But let's add the timestamp as well, because so let's get an epoch here. Yeah. Good. And now I'm going to send this. And as a key, let's use the same machine ID. So it's a 3D printer one. So now if we go here, we see that this message was received. You might be asking what I'm looking at. Well, this is just simple Flask service which exposed a post endpoint like this and just produce this message to Kafka topic. There's no more to it, okay? And this is on purpose. I don't want to put any logic in this API source, because if I do anything wrong in this service, the data are gone, okay? And I can't fix them. But I can fix anything I do wrong downstream here. So let's talk about that. So for example, let's call this HTTP normalization. And this is where I'm gonna comment out the output again and just gonna print the results. Nice. So we got that one message that I sent there. And here you see the first advantage of this approach. Well, I was not running this service when I sent that message, and yet I'm getting it. And that's going to be very important in a second. So here we see that this timestamp is different than this timestamp. Well, that's because we're sending the timestamp in the payload. We have to let the quick streams know where is the timestamp coming from, because this is a timestamp of sensor information being acquired on a machine, while this timestamp is when the message arrived to the perimeter of the data platform. That might be delayed. It might be important information for us later, but quite likely we are more interested in this timestamp. So what we can do is stop this and say, all right, so let's convert this timestamp to milliseconds first, because we work with milliseconds in a previous example. So we want to put it on the same level. So that would be something like that. And then let's assert, or let's set this column as our timestamp. And this has to be integer. Good. All right. And let's print it again and see. So now, because we control the production of the data, I can go here and send the message again. Okay, so that's easy. And now we see that these two timestamps are equal. But what if we don't? What if this is a machine, expensive machine somewhere, and we already lost the first message where we have produced the wrong data, wrong timestamp, you know? Well, this is exactly where the Kafka comes into the place. So if I stop this and I duplicate my view and go to topics, go to HTTP source topic, and go to consumers, and I produce this message again. So we have now 3 messages. Now, if I run this, I will get 1 message. That message that I missed when I was not listening. And here, soon, you will see that we have consumed 3 messages and we are at 100% of the topic. But what I can also do here is change the consumer group and replay all 3 messages again and correct the first message that we have produced wrong. Or actually, in our case, we haven't produced at all. So now you can see we have all 3 messages. We can switch to our previous print table. Amazing. So now we can stop this and we can actually put this to sensor data as well. We can call this not my transformation, but HTTP transformation and deploy it. And now we're gonna see here in a second another consumer group, and it will quickly go over all 4 messages, all 3 messages we have there. When this basically deploys, there we are. Now you see it's stable. And if I now send a message, you see it was for a moment 75%, and now it's 100%. So it crawls the leading edge immediately. So this is an advantage of using a data platform or data architecture powered by a distributed system like Kafka, because you have the resiliency of the data distribution between the services, database, etc. And you have a lock that I've just showed you now. So now you see the both sources actually ends up in this topic. So here we're gonna have both of them mixed together. So potentially if I now go here to maybe go to waveform, and we're gonna see 3D printer 1 here, okay? I can even get a fan speed. There we are. Now, if I here create a 3D printer 2, sorry, I think did I actually, yeah, I forget to do that. That's a nice mistake. So we have not produced any data yet with this service. So let's fix that with this deployment. So now you actually saw in practice exact problem. If I would not have Kafka now, all these messages would be lost. But because I just have the Kafka, now this service will produce this data. And as a result, here we're going to receive the 3D printer 2 soon. So if I get here 3D printer 2 as well, there we are, 3D printer 2. coming in. So this is the ingestion part. I hopefully it made sense. We also talk about, configuration management, which we have here, which we don't have time to go through a code, but here, for example, we have an S3 source, which is listening to files and converting XMLs to JSON and then syncing them. It's also another channel for your data or configuration, but you get the architecture. Is you have a source, you have a sinks, and you have a transformations. We're gonna continue in that pipeline. So now we have covered the ingestion, and we're gonna cover the steps right from the ingestion. So ingestion is on the left, and then you have the pre-processing, then you have a syncing to database, then you have the post-processing and data analytics, data visualization, how to build your reliable central store for your data. There's also things to cover. So yeah, if you have any questions, let me know. But all of this code is gonna be on GitHub, including all the configuration, so you can always reproduce it with basically a single click of a button, and follow my webinar by yourself if you want. And you can ask a question on our community Slack if you get stuck at any point. Yeah, so hopefully it made sense, and yeah, let us know.